All right. Welcome to Building Perl RPMs. I'm Dan Sterling. I work at +3. We have a CMS and do online fundraising, so check us out if you need to do some fundraising. I'm on Twitter and IRC. So I'm going to start out with an inadvisable live demo. So let's see what happens. I've got a Google Compute Engine instance. It's 2013. We should be using VMs, right? Cloud VMs. So I've got a set of files here we're going to work through. So I promised an exact step-by-step guide for how to build RPMs and Perl RPMs. So this is it. Start out with installing eqhl. This is assuming you're running on RHEL 6 or CentOS 6. RHEL 6 has Perl 5.10, 5.10.1 with a bunch of patches. RHEL 5 has Perl 5.8.8 with a bunch of patches. We try our best to get Red Hat to put the latest Perls in when they come out with a new RHEL release, but it's not always successful. So it's no 5.18, but it is 5.10 at least. So if you're on RHEL 6, you have at least that. And you can build your own Perl. That's outside the scope of this talk, but it is possible to build up your own Perl and package that. You can use the Fedora RPM packages as a base for that. So you start out with eqhl, and eqhl is extra packages for enterprise Linux. This is a set of additional packages on top of your base packages that come with Red Hat. And it's a volunteer project. You go on the Fedora eqhl mailing list and say, I need a package. Here's a spec file. Can you guys get this in? And they will. So that's how you install it. wget down the eqhl RPM and install it. Step 2, install your build packages. Screen, Joe, mock, RPM build, make GCC, etc. Some packages like to use mocking, so make a mock user. You never run RPM build as root, because RPM build likes to RM files in a lot of places and do a lot of other crazy commands that you really don't want to be running as root, and there's no need. So you always, that's where the mocking system comes in. It gives you a build environment that can do rootish things without needing to be root. You also see there I use Joe. Shout out to Joe. It's a WordStar clone. I hate VI. Ugh. So next step, import your GPG key. You have a GPG key, right? If not, create one. It's pretty easy. Export it on your main box, and then import it onto your build box, and also that public key imported into RPM as well. Pretty simple there. That lets you sign your packages, and you want to sign your packages for verification purposes. You know that the packages you're installing actually came from you, and also that they are valid, they haven't been corrupted. Next, set up your build environment. And by the way, is this big enough for everybody? This is on GitHub as well if you need to look at this. I will increase the font size. Set up your build environment. Pretty simple. You just need to build directories, and you need an RPM macros file. RPM build likes to use a lot of macros. It's kind of a sore subject because it's not documented very well, and they can do a lot of crazy things. But in this instance, you just need some macros saying who you are and where you put your directories for your build environment. All right, so let's start out with a quick build. What version of test simple do we have installed? Let's find out. And here's the live demo part. yminfo perl test simple. That's going to do a quick update or not. Bump down the font size just a touch there, maybe. Did that help? We're running 0.92, so let's upgrade that. So first you get your cpan spec installed. So cpan spec is a tool put together by some Fedora people that downloads from cpan your cpan distribution that you specify and creates a spec file. A spec file is what RPM build uses to actually do the build. It specifies how to do a build. So let's go into our source directory and tell cpan spec to pull down the latest test simple. All right, so that's actually going to go out and hit cpan and grab both the cpan package, the distribution file, and write a spec file. So we can take a quick look at that spec file. It's got metadata at the top, the name, the version, quick description, boilerplate stuff. And then the heart of the actual build, here's the macros again, a prep section and a setup macro to untar the package, your source file, your source package. Then it does the build, Perl makefile, it's all standard build, make, and then the actual install. It installs it into the build root, which is the place that RPM build actually takes and makes your package from. All the files in the build root directory are what actually constitutes your file. It's also a check, make test, cleanup, pretty simple stuff. Auto-generated spec file, so that's that. All right, so let's build it. We've got the spec file. Let's put our spec file in the RPM sources directory. That's obviously where RPM build looks to see where the source file is to build it. And then let's build it. Put in my passphrase for my GPG key. Your GPG key has a passphrase, right? It should. And that's it. We've got a Perl package. Now we need to install it. And we're upgrading it from the package that's already installed as part of what came in the CentOS or RHEL base packages in EPEL. That was what we were looking at before. Now we've got a new package. Is it live? Yum will tell us. It is. No. Yes. Available packages is updates. That's in the updates repo. And then it scrolled back past the installed repo has our new version that we just installed. And of course we can also verify that by running the actual module. So there it is, that's the version. Okay, that was horrible. Everything just broke. I upgraded a package. So, you know, all my servers are failing now. That was a mistake. So let's downgrade it. So here we're starting to see some of the advantages of having package management. We just made a mistake. Let's go back. Done. We've downgraded it to the version that we were using before. Did that work? Run yuminfo again. And yeah, 092 is installed. And if we run our Perl command again, it'll verify that. Pretty nice. So that was upgrading a package that's already in the CentOS or RHEL base or EPEL package repositories. What about something that we don't already have? Do we have roll-tiny? Let's find out. No, there's no roll-tiny. So let's build it. We need to install some dependencies. Test simple happens to be a dependency, so let's put that back in there. And all the other dependencies that are already in the base or EPEL repos. We're already in our source-dir. Pull it down from cpan. Move the spec file into the sources directory again. Or not the spec file, but the cpan distribution source file, and then run RPM build. And the BA says to build the package and a source package as well. So another advantage of RPMs is you get a RPM, which is the actual files that you want to install, and then you get a source RPM, which has all the source code and the spec file, so you can rebuild that if you need to on a different architecture, that kind of thing. Okay, so it's built. Let's install it. And it's installed. Is it live? We'll see in Yum that it is. And of course, here's another advantage of RPMs. You get that inventory. Yum will tell you what's on your system. You don't have to go and look through directories to try to find out what's installed. And then it actually works. There it is. All right, but that was a bad idea again, so let's get rid of it. And it's gone. So there we go. Easily add and remove cpan distributions Perl packages. And of course, we can run our commands again and see that it is in fact no longer with us. Gone. All right. That was all really easy, and it all worked really well, but we all know in real life that's not always how it works out. So what happens if we want to install a package where the dependencies aren't in the CentOS or EPEL repos? What if the latest versions that we need aren't in there? Well, we're going to have to create a package by hand for every dependency, which is going to be painful. But, and this is a huge mistake, and never do this, but let's cheat. So what if we can get cpan to build an RPM, a mega RPM that has all these dependencies included? Well, let's give it a try. Let's try it out with plaque. So let's do the same thing we did before with plaque. Have cpan spec pull it down and create our spec file. So plaque, of course, is the PSGI middleware and web server and all that Mayagawa's done excellent work with. So we've got our spec file, so let's just go ahead and try to build it real quick. Make sure our package is in, our source package is in the sources directory. What happens when we try to build it? Well, it's going to say no way, because when cpan spec took a look at your source package, it noticed, it looked through the Perl code, you know, simple pattern matching, and noticed it looks like you've got some dependencies here that aren't installed, so you're not going to be able to build that. All right, so let's get cpan installed from our repositories. Now again, this is using the system Perl, which is 5.10.1, and again, it is possible to use a newer Perl. It can be a little bit tricky, but it's definitely possible to do. Set up cpan, I've already done that, so I'll skip it for this live demo, but you can see obviously cpan's running there. Tell it to follow prerequisites automatically and to install any build requires automatically. And I could be using cpan minus, which is another nice Mayagawa tool to install packages, but cpan works, so let's just use it. And it's, of course, cpan minus isn't in the base or EPEL repos. All right, so let's take this package, this spec file that it's generated for us, and let's back it up. Copy it to an orig real quick, and let's copy from our documents a spec file that I've already got going on, and I discuss what the actual changes are here. I'll go into that in a second, but while that's happening, let's go ahead and build it. So we're going to build it real quick, and I'll go back up and discuss what the heck we actually did. All right, so that's building, and it's just running cpan like you would any other way, or from the command line to install a bunch of packages, but it's not installing them into your actual Perl directory. It's installing them into a build root, which RPM will package up. All right, so let's take a look while that's running and take a look at the differences between our, helps if I'm in the right directory. Take a look at the differences between our original spec file and the one that I modified. And again, I've documented the differences. So the build arch by default is no arch. Just comment that out and it'll automatically, RPM build will automatically use the right architecture. cpan spec puts in the build requires. That's where that error came from. We're just going to remove those because we're having cpan satisfy all the dependencies. What we're going to do to actually get cpan to do the build is use some tricks similar to what local lib and tools like that use, like Perl brew. And we're going to set these environment variables that tell makemaker and module build where to install the packages, in this case into our build root. And we also need to, as we install packages, they need to actually be used later by the later distributions that are being built. So we set our Perl 5 libraries and our path so that all that works. And then in the spec file we also, so I'll show you where all that is here in the spec file. And I'll get to, well, yeah, I do have that described. So here under prep, we are taking out this extraneous dependency. So again, RPM build uses a lot of macros that are very magical and very evil, and they don't always get the Perl dependencies right. One of the macros is goes through and greps the source code to look for dependencies. You know, if your Perl code says use Apache 2 log, then it'll or require Apache 2 log, then it'll add that as a dependency, even if it's not a real dependency. If it's in an eval, or sometimes if it's in docs that didn't notice for docs, that kind of thing. So it'll we're just wrapping that. We're wrapping the original Perl requires macro and removing the extraneous dependencies, but letting it actually apply all the dependencies that do need to be applied. Okay, so back to where I was here. So here's where we take out the original make and put in our cpan trick. And then we did another couple of tricks. We removed the debugging files in the Perl local pod file, which cpan creates to tell you what you've installed. That can't be in multiple packages, so we just remove it. And then we list the extra directories that we installed to under our files section. So let me show you the entire spec file that is modified here. So again, normal stuff at the top, description, version, prep section extracts the source package. Here's our trick to remove the extraneous requires that the RPM magic added. And then we move everything from the build section of RPM to the install section, because the install section is what writes to the build root, and we just want cpan to write everything directly to the build root. And then after that, we go ahead and do a quick make and make test again, just to be sure. And then our files section lists all of the places where we're going to be installing files when the package is installed. These are all the things that RPM actually puts into the package. And then there's a changelog. Okay, so did that finish building? Yes, took 3 minutes. 3 minutes, 11 seconds. Not too long to build all of those dependencies, and we can potentially scroll up and take a quick look at all the crazy stuff it did. Lots of tests, they all passed. If the test didn't pass, it would error out. Okay, so let's install this monstrosity. And this is an x86 package now, not just a no architecture package. And there it is. All right. Is it in Yum? Or is it in the RPM database? It is. All right, now we can use another advantage here of RPM. We can tell it what files from this package are installed, and it'll tell us. You've got something in user bin. That's from, I think, module build, I believe. You've got a new time high res, something wanted to upgrade my time high res or install it. You've got man files, man pages. ext utils maker got upgraded, HTTP server, obviously the Plaque stuff. So all of this stuff is in here, and that's all from that one RPM. And more RPM magic. What Perl modules does this crazy package provide to the system? All of these. So Apache log format compiler was one of the dependencies that they got rolled in. Develop stack trace. So we can see here all of the Perl packages, and these can be referenced by other spec files saying, hey, I need this package before I'll install. And the system will say, okay, you've got it. All right, so again, this is a horrible, horrible thing to do. Never do this. But it works. Now, once you've done this, which you won't, go back and build proper separate packages for all of those dependencies. Because one thing that this helps is if you have a dependency chain where you're trying to install an RPM that depends on another RPM, and it's a circle that you can't resolve, this will quite definitively resolve it, and then you can go back and create packages for each Perl module that you wouldn't have necessarily been able to create so easily before. So we'll get rid of it. And yeah, that's the actual spec file. And it's gone. So RPM, I think that's about time. I also have some slides that we didn't get to, but basically they say what RPM is, and you can go look them up on GitHub. This is a crisis about the macros. Spec files are just shell scripts, so that's an interesting point. It's convoluted because of the macro system, but when you get down to it, spec files are just shell scripts with some metadata in them and a weird way to run them. The default build takes a source file and configures, makes and installs it. Don't run it as root. This explains what the sections are. Install spec, or rather the build root directory. Everything that's listed in the file section gets put in the package. cpan spec is the tool you use to create the spec files. And that's what we went over very, very quickly. And again, this is on GitHub, linked from the talk page, so you can go look it up. Thank you. And any questions? Go ahead.
Just about that sort of mega RPM that you were creating. If you were to try to be lazy and just stick with that, and you had another one, I saw you had like time high res and stuff in there. If you had another one that also included time high res, you would start to run the Perl.
Yeah, you would be able to install one or the other package on a target system, but not both. So yeah, again, that's why you don't do that. You only have one package for distribution. But if you did do that, then just do all your builds with all of your packages installed that you want, and then it'll cumulatively just work. But yeah, but don't do that.
You can force them to install on top of each other.
You can do that as well. You can force it to install.
Is it possible to incrementally, do you know anything about the cloud hand talk that was done already?
Oh, God.
Unfortunately, I didn't get to that one.
Well, it allows you to hack the add ink hook, so
Okay.
It will actually pull the package down from cpan just long enough for you to run the script. So I'm wondering if there's a way to package this up with just Plaque's own files and run the tests and run it under CloudPan just long enough to run the tests to create a Plaque which would not be installable anymore, but it would be complete in and of itself, and then you'd be able to backfill all the other packages.
Yeah, that's definitely reasonable. You would do that by doing the actual build in the build section of the spec file instead of doing it in the install like the hack did. So yeah, that sounds reasonable-ish. Yeah. Any other questions?
The tool that you use to build the spec file, what was that again?
cpan spec is the name of it. And that pulls down the spec, or pulls down the cpan distribution from cpan, creates a spec file based on that.
People need to know there's a cpan to RPM that's outdated.
There is, yeah. There's an older tool called cpan number 2 RPM that usually works, but it's old and don't use it. Use the newer one that Fedora is actually maintaining.
So,
Go ahead.
instead of making the mega RPM, why not build all RPM separately, write a nice little script that'll actually build more unique?
You could automate it, but it can be a bit of a pain because you want to go through each spec file by hand to verify it. Oftentimes you'll need to make changes to the spec file. So theoretically it can be automated, but in practice it requires, usually spec files require a little bit of tweaking, which my hand-picked examples didn't show so well. But yeah, yeah, more or less you can automate it. Any other questions? All right, thanks. Come see me if you have any more.